I blew the internal fuse on this. What I'm gonna do is just put my own fuse in it on the outside, so that way something like that doesn't happen again. Also, I'm gonna mark the wiring this time so I don't make the same mistake. But so looking at the board in here, it has a capacitor. So this is, it puts out, let's see, where is it? 120 watts, but 240 peak. So the peak is being given by the capacitor. So for some nerd time here, we're 120 watts divided by 115. So basically our amp output that we need to fuse it to is so it's really a ratio of 1 there, but this is, we've got to think that we're fusing the DC side. So we need to do 120 watts divided by 12 volts, which is going to give us 120, that's 10 amps. So I'm going to put an external 10 amp fuse on this thing, so I don't have that problem again. Got my hot here. I am going to put a 10 amp fuse in this. There we go. And I'll cut it so I can splice to it. So on 12 volt DC plugs, the hot is right here. It's the top part. This is the negative. So I'm gonna cut this, attach to my hot side with my fuse. There we go. I'm gonna use my Klein crimpers again. There we go. That's nice and tight. Alrighty. Now I'll cut the negative side off. Splice this. Put this on here. Go, that's solid. Heat shrink this all together and then put some more Velcro on this side because the other one didn't come off too well. I'll just trim a little bit off there. Slap this puppy back on there. This time I'll get the positive on the right side. Always make sure you do your positive first. It's just a little safer. Less chance of a little bit of getting zapped. I'm missing one washer. Oh, there it is. There you go. No explosions this time, no sparking, no zapping, so winner chicken dinner. Screw these things on. And we'll do a little fan test here. See what happens later. I'll make it pretty. Turn the fan off. We got a green light on the inverter, so that's always a positive sign. And ta-da! Okay, two things that I normally like to do. I like to take my voltmeter and just see what the voltage is on the pack. I did not do this at the beginning, but it hadn't run that long. It's still at 13.15 volts. And then, so it's really not drawing very quickly. Another thing I like to do on a new build is just take this is just a Ryobi heat gun, and let's see what kind of temps we're pulling on things. I like to check any kind of connections to make sure there's not problems there. Connection. Now inverters have fans in them. They actually generate quite a bit of heat anyway, so I want to make sure it's not overheat, but do expect it to run a little warmer. I mean, it's only 83 degrees. The table's 79, so it's not running very hot. The other thing I like to check the battery pack and the BMS, and they're both they're the same temperature as the table. So besides so that means we have great connections. The only thing that is getting a little more heat is the inverter, which is natural, and 4 degrees over ambient is very good. So anyway, we're gonna let this fan run. I've got a timer on it. Who knows how long it's gonna run on this battery pack, because this battery pack is 39 amp hours. I mean, it could run 2 days, I don't know. So we'll see what it does. Sorry the shop is such a mess. I had to come inside. I was doing this originally outside, but we had 3 big builds back to back. And so the golf cart one just got put up and we got done with it, so everything is hectic. I gotta reorganize this weekend. But anyway, if you like these videos, please like and subscribe below. Put comments in the comment section. And if you have some ideas or things like that, send them to the email that's attached to the YouTube account. And we will try to work and see what we can do there. Anyway, a lot more fun stuff to come. I'm excited because we're getting out of, I wanted to do education and show people a few things, but I really like building the packs better than some of the more basic stuff. So anyway, I'm ready to do some fun stuff, and you'll enjoy it. So please like and subscribe. Thank you.